Let's look at number 5. I see a square root. Kind of looks like tangent because it's in the format of u squared plus a squared. So I know that u is 5x and a is 2. So I'm going to go with tangent because of that plus sign. And I know that tangent is opposite over adjacent. And I have my hypotenuse. So I have the tangent of theta is 5x over 2. Again, I'm going to multiply both sides by 2. It's just easier to take the derivative of for me. All right, so take the derivative of tangent and I get secant squared. So I look over here in my formula, my problem, and I just need dx. So I've got to get rid of that 5. So I need to divide both sides by 5. And that gives me dx. Let's see, what else do I need? Ooh, I need x again. So I guess I need to divide this by 5. And that gives me just x. I'll have to raise it to the 4th power. But now I need my square root. So I go to my triangle, that side and that side. Again, adjacents and hypotenuses. That would be cosine or secant, and I'm going to choose secant. So that would be hypotenuse over adjacent, and I'm going to multiply both sides by 2 to get that square root by itself. Okay, so I've got dx, I've got x, and I've got my square root. So again, making those substitutions. So my square root is 2 secant theta. My dx is 2/5 secant squared theta d theta. On the bottom I have x, which is 2/5 tangent theta, and all of that is raised to the 4th power. Okay, so the first thing I'm going to do is I'm going to take care of all those constants. Ugh. Okay, so let's see if we can get some to reduce out. So I've got a 2 and a 2 and a 2 to the 4th power. So I believe that would leave me a 2 squared in the denominator, so otherwise known as 4. Okay, so I had a 2, and a 2 to the 4th. That leaves me 2 squared in the denominator. All right, now this is what gets really weird. Okay, your 5s, because it's a fraction. Okay, so what I have is I have 1/5 on top divided by 1/5 to the 4th power on the bottom. So just using basic math, we have 1/5 divided by 1/5 to the 4th. That's 1/5 times that, which leaves you a 5 cubed in the denominator. So that's going to be 5 cubed, I'm sorry, numerator. I said denominator, numerator. Okay, so that takes care of all those constants. Now let's see, I have secant times secant squared, that's secant cubed, over tangent to the 4th. Well, that doesn't look pretty, does it? So let's see if we can make it a little bit better. So we have 125 over 4. Then what is secant cubed? It is equivalent to 1 over cosine cubed. Now tangent is sine over cosine, but since it's in the denominator, we need to flip that or take the reciprocal, and that would be to the 4th power. Well, that's looking a little bit better. So we have 125 over 4. Then I can reduce my cosines. That would leave cosine theta d theta over sine to the 4th theta. So that's 125 fourth sine to the negative 4th theta cosine theta d theta. This is something I know how to do. If I let u be the sine of theta, that would be my du. So I could just use the power rule. That's kind of nice. So I have 125 fourths times, this would be the sine to the negative 3 power divided by negative 3 plus c. So combining that, that's 125 over negative 12. And then this would be 1 over sine cubed theta. All right, so what is sine? Again, I'm going to go look at my paper. I'm not seeing it, not seeing it. Go back to my triangle. The sine is opposite over hypotenuse. So my sine of theta is 5x over the square root of 25x squared plus 4. But since in my integral my sine is in the denominator, all right, I would take the reciprocal. So 1 over the sine of theta is going to be the square root of 25x squared plus 4 divided by 5x. I'm doing that again because in the integral my sine is in the denominator. So I have 125 over negative 12, and then I have the square root of 25x squared plus 4 over 5x, and that's all to the third power. Okay, last example. The 3/2. What does that mean? What is something to the 3/2? That really means the square root cubed. So the first thing I'm going to do is I'm going to rewrite this integral as 1 over the square root of x squared plus 5 cubed. Now it looks kind of like all those other problems. It has a plus, it's got a square root, looks like in the form of u squared plus a squared, where u would be x, a would be, oh, not 5. If a squared is 5, then a is the square root of 5. And then I'm going to choose tangent, so tangent of theta being u over a would be x over the square root of 5, and this would give me x squared plus 5, the square root of that. So I have the tangent of theta is u over a, multiplying both sides by the square root of 5, because I need to find the derivative. Okay, so that tells me what dx is. So the only other thing I need to know is what the square root is. So I'll use that side, and that would be secant of theta is hypotenuse over adjacent. Okay, I think I've got everything I need. I have a dx, and I have my square root. So rewriting this, so 1 times dx, so that would be the square root of 5, secant squared theta d theta, that's my dx, divided by my square root. What's my square root? The square root of 5 secant theta, and all of that is cubed. Okay, so again, looking at the constants, I have a square root of 5 over the square root of 5 cubed. Square root of 5 over the square root of 5 cubed. Square root of 5 times the square root of 5 is just 5, and that's in the denominator. Then, let's see, I have secant squared over secant cubed. So that would leave me a secant in the denominator. Well, what's the reciprocal of secant? Yes, the cosine. I know how to integrate cosine. It is the sine. So this is the sine of theta plus c. Not done, not done. I need to know what x is. So look on my paper. Do I have the sine? No, but I have my triangle, and sine is opposite over hypotenuse. Opposite over hypotenuse. So this is 1/5 opposite over hypotenuse. So again, choose which triangle by looking at the square root that you might have. Does it have a plus? It's tangent. If it has a minus, you've got to look at the order and go from there.